I know you're totally jazzed about voltaic cells, which is why we're going to keep going. This time, however, we're going to look at some non-standard conditions. What happens when we change things up? I don't know, let's find out. Basically, we're going to explain whether the cell potential will increase, decrease, or remain the same when the concentrations of solutions in the half cells are at non-standard conditions, so when they're not 1 molar. How does that affect the cell potential? So, non-standard conditions in a voltaic cell are present when the concentrations of the solutions in the half cell compartments are not 1 molar. Alright, so the voltage of the cell is dependent on the concentrations of reactants and products, and we can calculate that using the Nernst equation. Now, this equation looks really intense, but basically, if you're trying to find the cell potential under non-standard conditions, that is equal to the cell potential under standard conditions, and we can tell this is standard because of that little knot, minus RT over NF times the natural log of Q. So minus that universal gas constant times our temperature in Kelvin over number of moles of electrons transferred times Faraday's constant times the natural log of our reaction quotient Q, or the ratio of products to reactants. Now, the Nernst equation is often used when we're at room temperature conditions, or 25 degrees Celsius. So we can simplify the Nernst equation to something like this. Basically, what we've done is we've taken care of the temperature, the gas constant, and Faraday's constant to give us an equation that is a little more simplified. And your focus in this equation should really be on the reaction quotient Q, or the ratio between products and reactants in your electrochemical cell. So, what does Nernst equation tell us? It tells us that as the concentration of the products of a redox reaction increases, the value of the reaction quotient Q will increase. Therefore, the voltage will decrease according to our Nernst equation. So, when there's more product than reactant, Q is greater than 1. And we take the log of a value greater than 1, you get a positive number. So ultimately what's going to happen is you're going to be subtracting a positive number from the standard cell potential, decreasing the potential under these non-standard conditions. Conversely, when Q value is less than 1, when you have more reactant than product, when you take the log value of a number less than 1, so you take the log of a number less than 1, you get a negative number. Subtracting a negative number from your standard potential is going to increase your cell potential under those non-standard conditions. Math. Now, there is a really great image in your notes that sets 2 voltaic cells side by side. One of them is under standard conditions, one of them is under non-standard conditions. What you want to focus on is the concentrations of the aqueous ions in solution of their respective half cells. Under standard conditions, those values are 1 molar solutions. If you were to determine a Q value here, 1 over 1 is 1. Taking the log of 1 gives us 0. So we don't subtract anything here. That gives us just our standard conditions. But think about what happens here under our non-standard conditions. The concentration of our reactant is 2 molar. The concentration of our product is 0.01 molar. We have a much higher concentration of reactant than we have product, which means that we're going to have a Q value that's less than 1. When you take the log of a number less than 1, you get a negative value. Subtracting that negative value will give you a larger cell potential overall. Remember, your Q is only going to involve the aqueous parts of your equation. You don't have to worry about the solid components when we're talking about determining the value of Q. It's also important to note that the Nernst equation is no longer on the AP exam, and so you won't find it on your formula chart. But I find it still really helpful when trying to explain what is going to happen to our cell potential under non-standard conditions. And you still have to be able to do that for the AP exam. Now, you only have to talk about it in terms of Q, but I find it helpful to refer to the full Nernst equation. All right, and that is it. Have a fantastic day.